All right, this will be video number 3, decompression theories and dive tables. Here we go. All right, who here has been diving with a dive buddy and their dive computer had them bringing their dive to an end before you or vice versa due to getting close to the no decompression limit? Did you ever wonder or realize why? So this is what we're going to get into in this lesson. This is due to research associated with the decompression theory and the algorithm that the dive computer was programmed to. We will learn about theoretical tissue or compartment half times, understand why NAUI uses the modified US Navy dive tables, and work with dive table calculation objectives and learn various dive table procedures. Okay. As we extend our diving range and meet or dive with other divers, possibly in new regions or countries, we may find that they're using unfamiliar tables, or they may be diving with computers that are more or less conservative than our own. We're going to familiarize ourselves with the different theories that these tables are based on. Okay. First theory we're going to look at is the Haldane theory. That was developed by the scientist Haldane. Haldane observed animal subjects saturated at depths shallower than 33 feet of seawater. They could surface without showing any signs of the bends. Surfacing from 33 feet of seawater or ascending from 99 feet to 33 feet is what's called a total pressure reduction of 50%. These implications led to the Haldane ratio principle of 2:1, meaning that tissues could always withstand a pressure reduction of 50%. As an aside, later research modifies the ratio to approximately 1.58:1. All right, theoretical tissues or compartments were thought of as a way to model the body and analyze the absorption or elimination rates of gas defined by half times. Okay, the compartment half times is the time required to absorb or eliminate half of the pressure difference between what is started with and the ambient pressure it is exposed to. In other words, after the first half time, 50% of the gas would be gone and 50% would remain. After, say, the second half time, 50% of the remaining half time would be gone for a total of 75% gas gone. After the third half time, 87.5% of the excess gas has left the tissue. And then so on and so on. After 6 half times, 98% of the excess gas has gone, close to 100%. Haldane also proposed a method of stage decompression where the diver would ascend to the shallowest stop possible without exceeding this 2:1 ratio, remaining at the stop until enough gas has left the tissues. That's where we get our decompression diving from. Okay, next we're going to look at the US theory. It was developed in 1937. It was an evolution from the Haldane theory. Key differences being that they used surfacing ratios for different tissues versus just one tissue, and only looking at inert gases such as nitrogen, because the thought is oxygen is metabolized in the tissue. All right, from there you get the US Navy decompression model that was developed by 1965. This is where your no decompression diving is established. All right, US made a U.S. Navy made a major addition to the Haldane model with the concept of repetitive diving. This is where, with the invention of scuba, now diving was looked at with respect to actually coming to the surface and off-gassing some of that nitrogen. As the U.S. Navy dive table showed, like today's dive tables, divers were assigned to a letter group based on the pressure on surfacing. While at the surface, the nitrogen leaves the body, producing a reduced letter group. On returning to the water, the new letter group is used to determine the residual nitrogen time at the dive depth. Residual nitrogen time is considered as time already spent at the repetitive dive depth. Okay. Other dive theories is the British theory. It's also a descendant of the Haldane Royal Navy tables. This is a more conservative surfacing ratio than the US tables, providing less time at depth. This theory is extremely conservative, repetitive dive procedure, whereas dives were counted as a single dive regardless of surface interval. All right, another theory is the Swiss theory developed by Professor Bowman. Its difference is it allows for altitude diving, unlike the British and the American theories. This theory actually complicates an already complex situation, but today's tables and computers are based on theory and are produced and are usable at reduced atmospheric pressures. Another theory is the Canadian theory. This is different in that it wasn't derived from Haldane. This is a theory stating that the tissues takes up and gives off gas from the environment versus ambient pressure. And then your second and succeeding tissues takes up and gives off gas from the preceding tissue. Okay. These theories are also more conservative than U.S. Navy tables. All right, next we're going to look at dive tables. We got an example of a NAUI dive table here on the right. NAUI recommends the use of the U.S. Navy tables as modified for recreational diving. This is due to more information and data being available for Navy tables than any other tables in existence. To conform with latest U.S. Navy dive tables, the NAUI dive table recommends a stop in the 10 to 20 foot range for 3 to 5 minutes when diving deeper than 60 feet. It recommends a max rate of descent of 75 feet a minute and a max rate of ascent of 30 feet a minute. NAUI also endorses the Canadian and the Swiss tables. All right, some special dive table procedures with cold or strenuous dives. It recommends to actually, when using the dive table, look at the next time, based on a given depth. All right, ascent rate variations. Let's see, from this point, we could say when using dive tables, ascent times slower than 30 feet a minute add little benefit compared to a stop. It may even add to the diver's nitrogen load. Okay. When using a dive computer, it is essential to follow the ascent time required by the computer. That's one of the benefits of diving by a dive computer. All right, another special dive table procedure: surface intervals less than 10 minutes. If your dive time is less than 10 minutes, the 2 dives are considered to be a single dive. surface interval time is ignored. All right, in multi-level diving, procedures have actually been developed to manually calculate multi-level dives, but they're not recommended because of the errors that you may incur. So again, dive with a dive computer. It's recommended. All right, omitted decompression. Let's see, the old procedure of recompressing the dive ring water has been replaced with getting the diver out of the water, resting, breathing 100% oxygen. That's a common, I guess, medicine for decompression sickness or other dive injuries. Drink plenty of fluids and monitor for decompression sickness. From there, a possible transport to a hyperbaric facility if symptoms of DCS are suspected. Let's see, a special dive table procedure for flying after diving. Limit flying in an unpressurized aircraft to an altitude of 8,000 feet. Wait at least 24 hours before flying. Following a single no compression dive, if doing multiple dives, the recommendation is wait at least 18 hours. And then if you're doing your dive required decompression, waiting 24 hours. But usually to be on the safe side, I try to get in that 18 to 24 hour time range before I fly. All right, in summary, there are many different decompression theories and tables applying to different or highly specific circumstances. It is important to understand the background of some of the prevailing theories so that appropriate techniques can be used for your diving situation. All that, and all the algorithms are pretty much combined into dive computers these days. Dive computers have become very popular with divers, and training is required to fully understand their use. More in-depth information can be obtained by taking the NAUI Master Scuba Diver course. So that'll be it for this topic. I'll see you on the next video. Just rescue. Bye-bye.